Hey guys, this looks like a fun one. We're given 6 squares and a quarter circle. We're given that this square has an area of 2, and we're trying to find the area of this square. This is another amazing puzzle by Catriona Agg. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, I'm trying to figure out what are we being told here? What are these squares all doing? The only thing I think we're really being told is this is in the corner. This touches the semicircle here and here, and this distance is equal to this distance. So for a second, let's call both these X. But I don't see what the orange and green are doing. If we get rid of the orange, I don't think anything changes. And same thing if we get rid of the green. So I think we don't need either one of those. We still have this information and all this. So I simplified things a little bit by getting rid of the green and the orange. Since the blue square has an area of 2, we know each of the sides are equal to the square root of 2. And the purple square shares a side with this square, so it also has side lengths as square root of 2. And I think that's everything we know. We do need to find the area of this yellow square, so let's label this y and this y. And ultimately, we're trying to find the area of this square, which will be y squared. So how are we going to do this? Well, let's copy this down here, and let's connect this intersection point from here to here, and this intersection point from here to here. Each of these are a radius of this semicircle. So let's copy it down again. Let's erase this one and draw it down here. And then let's draw this side and this side to complete this right triangle. And we can do the same thing down here. Let's draw this side and this side to complete this right triangle. Now we have 2 right triangles. Let's play around with them. First, let's look at the base of this triangle. This portion of this base of this right triangle is the same as this up here. It'll be equal to x, and this will be equal to y. So the whole thing is going to be equal to x plus y. Does that make sense, y? And then we can look at the hypotenuse. This is a radius of the semicircle. Let's label it r. And then we can focus on the height of the right triangle. This is equal to x, and this will be equal to root 2. So the whole side is equal to x plus root 2. Now we can write an equation using the Pythagorean theorem. It'll be the quantity x plus y squared plus the quantity x plus root 2 squared is equal to r squared. And then we can do the same thing for this triangle. The hypotenuse, once again, is a radius of the semicircle. It'll be equal to r. And then for the base of the triangle, this will be equal to y. This whole thing is going to be equal to x. And this portion outside of the triangle will be equal to square root of 2. So this portion of the base of the triangle is going to be equal to the whole thing x minus this square root of 2. And that means the whole base is equal to x plus y minus root 2. And then for the height of the triangle, this is equal to x, this is equal to root 2, and this is also equal to root 2. Root 2 plus root 2 is equal to 2 root 2, so the side length is equal to x plus 2 root 2. And now we can write another equation using the Pythagorean theorem. It'll be the quantity x plus y minus root 2 squared plus the quantity x plus 2 root 2 squared is equal to r squared. And now I think that's everything we can get out of these triangles. Let's play around with these equations. First, let's simplify the top one. The quantity x plus y squared is equal to x squared plus 2xy plus y squared. And the quantity x plus root 2 squared is equal to x squared plus 2 root 2x plus 2. And that's all still going to be equal to r squared. And then from here, we have 2x squared, so we can write down 2x squared and then copy down everything else. This looks important. Let's put a box around it. And then for this equation, when we multiply all this out, it's going to be this times this. So we have to do x times each of these, and then y times each of these, and then negative root 2 times each of these. Let's rearrange everything like this, and then we have x squared plus 2xy plus y squared plus 2 minus 2 of these root 2 x's, and then minus 2 of the root 2 y's. And then we can add to that this one, which is just x squared plus 4 root 2x plus 8, and that's still equal to r squared. On the left-hand side, we have x squared plus x squared is 2x squared. We can copy down the 2xy, copy down the y squared, and then positive 4 root 2x minus 2 root 2x is positive 2 root 2x. We can subtract the 2 root 2y, and 2 plus 8 is equal to 10. And then on the right-hand side, we still have r squared. This looks important. Let's put a box around it. And now let's get rid of everything not in a box, and let's compare the two boxed values. I see a lot of stuff in common. Let's try using elimination. Let's arrange things so the like terms are lined up, and let's subtract the two equations. On the left-hand side, all of this is going to cancel out, and then 0 minus minus negative 2 root 2y gives us positive 2 root 2y, and 2 minus 10 gives us negative 8. And that's going to be equal to r squared minus r squared, which is 0. We can copy this equation down here, and let's add 8 to both sides. On the left-hand side, we'll be left with 2 root 2y, and on the right-hand side, we'll have 8. Next, to get the y all by itself, we can divide both sides by 2 root 2. On the left-hand side, we have y, and on the right-hand side, we have 8 divided by 2 root 2. This 8 can simplify with the 2 on bottom to give us 4, and now we have a value for y. 4 divided by square root of 2. Let's clean all this stuff up and bring this up here. Next, to get the area of this square, we can square both sides. On the left-hand side, we have y squared, which is the area that we need. And on the right-hand side, the square can go to both the top and the bottom, giving us 4 squared over the square root of 2 squared. On top, 4 squared is equal to 16, and on bottom, the square root and the square are going to cancel each other out, leaving us with 2. 16 divided by 2 is equal to 8, and y squared is the area of our square. Let's give it a label of square units and put a box around it. In this given Catriona Agg puzzle, the area of the yellow square is equal to 8 square units. How exciting. And here's the next puzzle we're going to do. In this given right triangle, we're given that this tangent point of the circle splits the hypotenuse into 4 and 5. And it wants to know what is the area of the triangle. This looks like it's going to be a fun one. How exciting.